Hey there, folks. This is James Siegel with Openpath Security. I'm the president and co-founder of Openpath, and I'm here with my business partner, co-founder, and overall swell guy, Sammy Kamkar. Wave, Sammy. There we go. We've got an exciting presentation today to go through about access control. That's right. You've all been waiting for this. I know this is the reason that you're here at Octane today, and we deliver. So without any further ado, we're going to get into a presentation around OpenPath and our value prop for next generation access control. OpenPath is an access control company. That means we make the physical access control system that allows people to get into your buildings. My partners and I have been working together for just close to 20 years. This motley crew have built 4 different technology companies, and all of them have been solving problems for customers that we ourselves experience as entrepreneurs. We've raised a good amount of money, and one of the things I'm most proud of, especially on this call, is that Okta is an investor. We have a lot of joint integrations and joint customers between Okta and OpenPath. And over the growth of the company in the past couple of years, Okta recognized that access control was something critically important to both companies, enterprise businesses, and anyone with real estate. And they decided to make an investment in our last round, which we're super excited about. We've got great institutional investors and other strategics as well. The company itself was actually founded just 4 years ago. We came out of stealth mode in the summer of 2018, and here we are just a couple of years later, but we've gotten quite a lot of traction in that time. We're in over 34 million square feet of office space, deployed with about 18,000 doors, and over 600,000 users are using our system every day to unlock the doors to their buildings, offices, warehouses, and work. So it's pretty exciting. When you look at the kinds of buildings that we're in, they range from all kinds of venues like the LA Forum to big, tall skyscrapers, both apartment buildings, commercial real estate, office buildings, mixed use buildings all over the world. Uh, Companies that use us range in size and scale as well, and in industry verticals. So you'll see Domino's Pizza rolling us out across their pizza chains nationwide. Big enterprise companies like Stamps.com rolling us out across their office footprint globally. University of Virginia, sports teams like the LA Clippers or the Dallas Mavericks, and a host of others. You really kind of see us in a number of different verticals, but what I would say is we built the technology oriented around the enterprise and the commercial real estate footprint. And our channel partners, system integrators who install these systems every day, have started to also sell us into multifamily residential apartment buildings, retail, houses of worship, and education. So you really do find us anywhere where you've got a commercial grade electrified door with a reader, you'll find OpenPath. Let's talk a little bit about the origin story, how we got here. We're here because we are frustrated users. Our last company we sold to Verizon, and as part of that experience of having offices all over the world, having data centers all over the world, we had badges to access every single building. This is actually the badge pack my partner Alex and I would carry around just to get into our LA campus here in Los Angeles. But we had over 20 offices globally and 110 data centers. I literally had 130 badges. And it was just a pain. Everything about this was kind of disappointing and frustrating. One, because I had to carry them everywhere. But two, it didn't really help with our security posture. We found this kind of disconnect between the cybersecurity security policy of Verizon and any business we were running and the physical security policy. You see, badges are not very secure. Sammy's going to get into this a lot later, but what you'll find is you can copy and clone them pretty easily, even at a kiosk at your local supermarket. So we looked at this and we said, wow, badges are a pain. They're not secure. How do we use mobile, a disruptive technology, and cloud, another disruptive technology, to really change the way this industry reacts and responds to technology? We looked at mobile as a way that people could actually unlock their doors. We carry our phones with us everywhere. Well, why not have your credential to unlock the door on your phone? Turns out a lot of other people had the same idea. There's a bunch of different companies that make access control badges and make mobile credentials, HID, Brevo, Keysi, and a bunch of other folks. It turns out, however, that no one really wanted to use these mobile apps because they were difficult to use. When we entered the market, there was a very low adoption rate for mobile. What we found is that they were kind of missing the boat. The apps were hard to use, they were difficult to install, they didn't work reliably. When they did work, it took a long time to actually unlock the door. You'd stand in front of a door for 10 seconds, and you couldn't even move the app from one phone to another when you upgraded. What we noticed was there was an opportunity in the market not just to use mobile to unlock the door, but to also bring together the physical security and digital security strategies of the company by actually taking the badge, the credential that you use every day to verify that you are who you are and that you're supposed to be there, and giving it a digital twin. You see, we still need badges to verify who we are in a lot of different buildings. Think about when you go into a hospital, or if you're in a secure room or a secure building in a government or in a data center. You need to show that you belong. But having a digital twin gives you the flexibility to now also adapt to changes that happen around you. So let me give you an example. You can take the way that you design the badge and you can actually put it into the mobile credential, but you can add new capabilities to it that are dynamic. For instance, we can add stuff like vaccination status. You can see that right here. So that instead of reprinting everybody's badge, you can actually update the digital badge, the mobile ID, with things like vaccination status, status like essential worker, work group if you're time shifting your employees, all kinds of different things. It also gives you the ability to have a more secure way to enter, because you think about how secure phones are, right? Super encrypted. When you log into a phone, a lot of folks have a mobile software management policy that involves single sign-on in order to meet the compliance standards of their company. So we're rolling out an integration with Okta that allows you not just to do what we already do, which is to log into our web portal using SSO with Okta, but now your mobile app can actually authenticate with Okta, and you can use it to sign into your mobile experience. Again, additional security to make sure that we keep IT happy and meet all of our compliance standards. Some of the other features we thought about in this mobile app we're trying to make it super easy to use and reliable. And so we patented a really cool technology called triple unlock. What it does is it allows you to unlock the door using three different methods, sending a signal from your phone to the building. We send a signal over Bluetooth, Wi-Fi, and cellular at the same time, and we kind of pit those signals against each other. The first one to hit the access control system unlocks the door, and the other two are discarded. This gives us total reliability and a sub-second unlock experience. But one thing happened when we rolled this out to our customers. We realized in short order that people actually didn't want to use a mobile app. They didn't want to, dig around in their purse or their pocket, find their mobile phone, unlock it, find their OpenPath app, find the door, press the button. It was too much friction, right? They just wanted to take a badge and swipe it. So we had to go back to the drawing board and think long and hard about how do we improve this to make it frictionless? And that's where we developed our frictionless access, our wave to unlock technology. This is the ability for you to keep the phone in your purse, in your hand, in your pocket. Just walk up to the door, wave your hand, and the door unlocks. You see, we make a Bluetooth connection with the reader as soon as we get in range. And then waving your hand in front of the reader actually triggers our sensor to show that you intend to go in the building. So you're not just walking by. Now, you can set that as the door policy and make it really convenient, or you can upgrade the security posture of that door if you wanted to make it super secure. You could use two-factor authentication, for instance. So you could say, hey, before I wave to unlock, I have to first unlock my phone with my face, my fingerprint, or my code, and only then will it work to unlock the door. So we give you this great range of convenience and security depending on the security posture at the door. Now, what's really interesting is post-COVID, we all want to get back to the office. And if you combine our wave to unlock capability with an automatic door opener, you've got completely hands-free, germ-free ingress and egress into the building. And that's a powerful incentive to make your employees and all of your constituents know that you've invested in your real estate infrastructure to make it safe and healthy for them. But we do more than doors. We do parking garages, turnstiles, elevators, visitor management systems. The whole goal is every time you access a building, you should have a convenient and secure way to do it. And we've really tried to make the user experience as frictionless as possible. So let's look at the parking example. In parking, you want to be able to use your phone kind of as a clicker, right? You don't want to actually have to roll down your window and hold your phone out. You just drive up to the garage gate, press the button, and boom, the garage gate unlocks. Different experience when you go to a turnstile. When you walk up to a big building, you don't want to have to get your phone out, unlock it, find a QR code, hover it over an optical reader. Just brush your phone across the top of the reader with OpenPath, turnstile opens, and you walk in. Again, looking for every element that we can do to bring a better user experience to bear. And for visitors, we integrate with visitor management systems. So Envoy is a great partner of ours, actually someone that Okta uses as well. And so when you sign into the registration desk at an Envoy kiosk, they use our APIs to trigger what we call a visitor pass. This is the ability for you to get an email, just like we have right over here on the left, that allows you to, boom, decide whether you want to have virtual access on your phone without downloading an app. You see, I have these 3 different doors that I became accessible to as soon as I went ahead and clicked on the email link when I visited this customer. And then sure enough, right there I am, boom, ready to go. And I can actually get temporary access when I'm visiting. So let me show you how that works. So here we are, Keep Trucking. This is super exciting. I've got the Envoy integration with the mobile credential. So I'm a visitor here. I just came over here. Our OpenPath reader is installed right over here on the wall. You see that? And now all I have to do is just press this button right here. Boom, and it unlocks. I'm visiting, and now I have access. Yay! So you can see that we make the hardware. This is the reader and the panel that goes into the actual building. We make the software, in this case, the access control system that gets hosted in the cloud. We make the credentials, both the phone credentials and the key cards and fobs that you can use to unlock the door, as well as the APIs that are all hosted in the cloud. So a couple things I want to point out. First of all, if you have key cards today, we work with those key cards. Our readers are RFID compatible and they can read those cards. 2, if you have an access control system today, we use the wiring that's already in the building, and all you need to do is replace the reader and the panel, and it's easy to go. So you don't have to replace all the wiring, which can be super expensive. You see, when we built our system, we took into account the fact that we wanted to make it all work seamlessly and easily. So we've got single door controllers that can be mounted right above your door, all the way up to full campus-wide systems that can be mounted in the IT closet and can handle tens and tens of doors. All of them run our software locally so that if the internet goes out, our system will work flawlessly. It'll continue to unlock the doors, no problem. And as soon as the internet comes back up and running, you'll get the latest configuration changes and updates from the cloud. And of course, all of our software is sitting in the cloud and connected to our robust API platform. So the panels that get installed in the IT closet, this is the hardware we make. They can scale up to handle any door density that you have in your office or in your building. Our readers are also super convenient and super gorgeous. They've won a number of design awards. They fit beautifully into the door or onto the door frame with the mullion or gangbox version. They come in white and black. They support low frequency and high frequency credentials, which means you can handle encryption if you want. And we've got great support for iOS and Android. When it comes to open standards, we thought a lot about future-proofing the access control installation that you're doing. And so all of our panels, which you see here on the left, use the open communication standards of WEGAN and OSDP to make sure that all of the readers that you've already purchased and have running in your building will still communicate with our system. That means you can buy OpenPath readers to have that magical hands-free experience at the door, or you can use the keypads and readers that you've already got, or even fingerprint scanners or facial recognition tools or biometric tools. Those will work as well as IoT buttons. So you've got lots of flexibility, and you can reuse the hardware that you've already invested in. Now, we run as a standalone access control system. If you're an enterprise and you want to deploy a great system, OpenPath is a complete choice for you. But we also have various situations where we'll need to run alongside a legacy system. If you're migrating your company over to an access control system like OpenPath, you might want to deploy us in one building to start and then gradually move us across your campus or portfolio. Not a problem. We run alongside legacy systems in a hybrid mode, and we can mobile enable and cloud enable that legacy system while still keeping it in place. Our cloud software is done the way it's supposed to be. That means we built it natively into the cloud when we started the company. We didn't port a legacy on-prem system to the cloud. Instead, what we did is we said, look, we want to build this to scale so that you can add sites, add users, add all kinds of scaling capacity without really worrying about managing servers or virtual hosts or any kind of instances like that. Everything we built is built off of our APIs, which leverage all kinds of integrations and an ecosystem of software and hardware partners that love working with OpenPath. You can see here just a few of the different brands, but what I wanted to do was give you a couple of examples. So the best example I can think of is Okta. When you integrate Okta with OpenPath, you get instant synchronization between the directory service that manages all of the people in your organization and the access control system that manages their physical access to your properties. This means as soon as you hire someone new and add them to Okta, they're instantly added to the access control system and issued a credential. They can come and go with access to the right doors and right buildings. Now, as soon as that person's terminated or let go, they're instantly removed from OpenPath when you remove them from Okta, which means there's no orphan credentials running around. There's nobody who's been let go who's using an access badge that maybe still might be valid. Everything is synchronized in real time. And this is a combination now that brings your physical security strategy and your cybersecurity strategy together and makes it work really tightly. Our framework of open APIs is available to anybody who wants to integrate. That means we have a robust developer community on our website. You can come, you can see it. You don't have to sign a license agreement to integrate with our stuff. Just use it and develop. We've got other partners that actually build mobile apps. So these are folks that have taken the experience that a tenant or an employee wants to have and embedded our mobile credential right within their application. Examples like HQO and Rise Buildings. Suffice it to say, if you want to have a mobile experience that's unique and customized to your organization, you can take OpenPath's mobile access credential and embed it within your own employee app to create a single download so that your employees are not having to download multiple apps. Certified and compliant, obviously super important because security matters a tremendous amount in this world that we live in. We're SOC 2, we're GDPR, we've got all the hardware certifications. And from a security perspective, we care a lot about making sure that we don't store any kind of customer information on the edge devices that are exposed to users. So our reader, which is mounted on the wall outside of the building, is actually storing nothing. It's a pass-through device. As the phone sends an unlock command to the access control system, it just passes through the reader. Nothing's stored on the device. And when we send information from either the mobile phone, the cloud, or the panel in the IT closet, we're doing so encrypted. It's TLS encryption over a proprietary protocol that allows us to make sure that everything is end-to-end, also rotating security certificates. And Sammy can get into that in a whole lot more detail later. From a safety and security perspective, we also care a lot about the return to work strategy that many of our customers are thinking through now post-pandemic. Our hands-free access is certainly relevant, right? You don't want to touch a common surface to unlock a door. But we also have occupancy management capabilities where we can limit the number of people that come into a certain room. That way, when you say, hey, look, the capacity for this room is 20 people, as soon as you reach that 20-person limit, we basically revoke credentials to allow no more unlocks on that door until the room goes below threshold. Now, for wellness and verifications, partners like Envoy offer a mobile ability for you to fill out a form, a wellness or health verification, to say, hey, I don't have a temperature, I don't have COVID, I haven't been traveling. And once you fill that out, your mobile credential on OpenPath or your key card will be enacted and it will actually work. If you haven't filled out the form or if you haven't filled it out correctly, we will make sure that your credential does not allow you into the building. And we do the same with our integrations with temperature screening systems as well. So that if you have a temperature, your credential will not work and will not allow you into the building. Other cool technology that's really relevant to how you think about physical security are the integrations we have with video surveillance systems. So Cisco Meraki is one of our biggest partnerships that we've announced today, but we integrate with a whole host of other video, cloud, and on-premise video surveillance systems from Rhombus, Cameo, Milestone, and Vion. And then, of course, we have lockdown capabilities. This is the ability for your physical team on site to lock down a building in case of an active shooter, to alert authorities in case of an event, or on the opposite use case, if there's an emergency like a tornado, a hurricane, or an earthquake, and you need to open all the doors, we can do a lock open situation that allows people to quickly get out of the building, out of harm's way, or to a shelter. Tailgating solutions as well through our integration partners so that you can track somebody sneaking in behind someone else. Again, the whole goal is to make your physical security as good as your cybersecurity. Well, with that, I'm going to hand the conversation over to Sammy Kamkar, my co-founder and partner, to talk a little bit about some of the cool investigations that he's done around physical security and how the physical access vulnerabilities are really quite an exposure. Sammy, it's all yours.
So we're all familiar with physical locks and metal keys. We all have them on our doors at home. But these pose a pretty big challenge when you're talking about large organizations or even small organizations, when you have multiple doors or you have many users. The biggest issue that has occurred is key management. How do you ensure with a metal lock or a cylinder lock where there's only one unique key, you can duplicate that key and give it to a number of users. But whenever you need to, let's say someone leaves the organization, you then need to rekey every lock. Then you need to get new keys, duplicate them, and then send them out to everybody. Now, this has since been resolved by electronic access control. And here we can actually see one of the oldest keys in use. I mean, keys have been around literally locks and keys have been around for thousands of years. I mean, since Mesopotamia, that archaeologists have actually found locks and physical keys that were able to unlock those. And if we look at the next slide, we can see a typical access control system. On the left, you have your user and they have some type of credential. So that might be an RFID card or a PIN or a mag stripe card. And then typically these days, you see a lot of RFID cards, and then you'll have your reader. And your reader is on the unsecured side of the door. It's next to the door. So you walk up to the door and you'll often present something like your RFID card. And there's a wireless RF field or radio frequency field that energizes the card and then spits out an ID back to that reader. And then that reader in the center is wired back to the access panel in a secured closet. And that panel then makes the decision whether to unlock that door or not. But as James mentioned, there were a bunch of different issues that we ran into and that we learned about, and security is one of the biggest things that we saw. So in our next slide, we see that the first issue is the cards themselves. If I can actually obtain your card, if I can temporarily have access to it, I can then extract the ID, the unique ID. And the next slide, we see a card, a transparent card. So inside of these is basically a copper coil, and that acts as an antenna and a chip. And that chip contains a unique ID. And when that ID is in, or when that card is in this radio field, it will then spit out that ID. Now that I have that ID, assuming that I've had access to somebody's card momentarily, then what I can do is not only can I use your ID, but I can actually brute force other users because IDs are very similar to each other. So for example, if I were to get a person in a building and I temporarily had access to their card, maybe they don't have access to all of the doors, but I can then brute force or just increment their ID to higher and higher IDs until I find someone who does have access to the doors I want. So we found this was an issue and immediately determined, okay, we shouldn't just use IDs that are spit out on cards, and we decided to use mobile devices. So our mobile device actually creates a separate private public key pair using TLS or SSL encryption so that even if someone temporarily had access to your mobile device, let's say, they can't extract that key. Now, on the next slide, we see there's also the wireless communication. We found an issue with the wireless communication between the cards and the readers. Next slide, please. And here we can actually see I have an off-the-shelf device, and just by placing one of these proximity cards in front of it, about a meter away, it's able to then clone and actually grab that ID. I can now take that ID and actually enter as that person. Now, imagine taking one of those devices, throwing it in your backpack, walking around campus. All you're doing is collecting IDs all day. And really, it only takes one to get into a building, and it only takes that one to actually start getting additional access and additional privilege by performing that brute force attack. Now we see the reader itself. The reader is on the unsecured side of the door. It's what you present your credential with, whether it's a mobile badge or a physical card. And on the next slide here, we see that the reader, since companies have discovered that many of these cards are unencrypted and they're now getting copied, cloned, brute force, etc., companies have started to create encryption. So cryptographic algorithms that sit on the card and the reader. And there are a couple challenges here. For one, most readers out there are not upgradable. So when there's a vulnerability, let's say we're actually looking at an electron microscope image of a chip. So a security researcher took one of these RFID cards that were encrypted, used acetone to melt the plastic, to extract the chip from the card, and then used a razor blade to literally remove the epoxy off the chip. Once he did that, he put it under a microscope, which we see here, and then optically looked at it and was able to reverse engineer the protocol, the cryptographic protocol. He then found a vulnerability. Now, security vulnerabilities are common. They happen all the time. We're used to them on our computers, on our phones, etc. But the nice thing is we have the ability to update software. On your mobile device, on your computer, on your tablet, you typically update your software or it will update it for you automatically. Most readers don't have that capability. And if you take a look at cards, there's absolutely no possibility of upgrading the card. So when a vulnerability like this that we're seeing here was discovered with this cryptographic cipher that has several flaws, well, now there are tens of billions of encrypted cards that are no longer encrypted. They're actually all unencrypted now because this was broken. And the only way to resolve this is to replace all of those cards and all of those readers. We've prevented this in a number of ways. For one, our reader itself is upgradable. It's connected to your controller, which is connected to the internet and gets over-the-air updates. There is no need to ever click update. There's no need to ever do anything or roll a truck to actually have that upgraded. It's all done automatically. Additionally, because it's upgradable, anytime a cryptographic standard is broken, we can update that. And because our software is mobile, that's also automatically updated. If there were ever a vulnerability, we'd be able to update it overnight while you sleep. And now we come to the wiring. So let's just assume for a moment that you did have a system that did have the level of encryption that we use. We don't know of any today, but I'm sure some people will follow suit at some point. And let's say they did have a reader. And another issue that we on the reader is that there are keys. So if you are using encrypted credentials, then typically people would store the keys on the reader. The challenge here is that the reader is on the unsecured side of the door. So if an attacker goes up to the reader, they're actually able to use a device and extract the key from the reader. That's actually happening today. We've resolved this by not putting any cryptographic information or secret material on our readers. All of our secret material is on the access control on the right side here, which is on the secured side of the door or in a secured network closet or IDF closet. Now, there's still the reader wired all the way to the access controller. Now, if you look at an existing system, they're using traditional weekend or RS-45 wiring. And the big issue here is that virtually all of that communication is unencrypted. We see a video. This is an off-the-shelf device that you can buy online. And what people have done is it takes less than a minute for this person to actually install this device. They take a standard reader. Virtually all readers communicate via these protocols. They open it up, and in under a minute, they're able to install this device. They don't even have to remove any wiring. And it's gaining power from the device itself, so it doesn't require battery or anything else. Whenever someone presents a card to the device from then on, that added device records the ID and then allows the attacker to replay it at a future time. So someone comes in, installs this device in under a minute, and then they walk away. They come back a week later. They now have the lists and lists of everyone who ID'd in, who badged in. Even if those cards were encrypted, even if the cryptographic protocols weren't broken, they would be able to replay on the unencrypted side of the wiring because the reader's on the unsecured side of the door. So we've resolved that by actually doing end-to-end encryption. We see that we have the badge on the left or the mobile device on the left, and we have the access controller on the right. Well, our encryption is all the way from the card or the mobile device all the way to the access controller. So we don't care if someone sniffs the wireless communication. We don't care if someone modifies the reader on that secured side of the door. And we don't care if someone is listening to the wiring between the reader and the access controller because it's all encrypted end to end. And finally, we have what's circled here, which is the access controller. And one of the major issues that we see is actually management. Actual management of these systems is really difficult today. It either requires truck rolls for people to come out to resolve issues. Whenever there's a security issue, someone needs to drive in and actually perform an upgrade, actually bring software and do that upgrade. Our upgrades are done all over the internet. And another big issue is user and permission management. How do you actually ensure that all the users that should be gone are gone? How do you ensure that permissions are correct? Well, because we've teamed up with Okta and we work with other identity providers, all of that is entirely automatic. You just click a button to tie into Okta, and now all of your permissions, your entries, your information is stored on the system. And if a user leaves the system or they change the group that they're part of, that's automatic. You don't need to go into any interface and do any updates. It simply clones the information that is in that system. So that's some of the vulnerabilities that we've found and some of the things that we've done to really improve the system. So back to you, James.
Thanks, Sammy. As always, you scare me with all of your absolutely insightful security analysis. I'm glad you're working on my side of the problem and not the other side. You're welcome. There we go. So look, what I wanted to do, now that we've kind of gone through the OpenPath value proposition and some of the security vulnerabilities in both the physical and cybersecurity world. So I wanted to talk to someone who's actually using OpenPath every day, and who better than Brooke Learman from Okta, who is a customer of OpenPath. Brooke, it is great to have you here.
Thank you, James. It's great to be here.
Excellent. Well, we are delighted that you are both a customer, an investor, and an integration and technology partner. I guess I wanted to start by having a little bit of a fireside chat and finding out about your journey getting here in terms of Okta and the challenges that you ran into around physical access control. So could you share a little bit about, how you got to a point where you thought about OpenPath and upgrading your physical access control system?
Yeah, absolutely. We have been working on a new way of working, and we call that dynamic work at Okta. And we've been working on it for a couple years now. At the core of dynamic work is really the concept of flexibility. As a company, we want the ability to be flexible and hire the best and most diverse talent wherever they might live. And for our employees, we really want them to have that flexibility to work where they will be the most productive. As part of this flexibility, though, we want them to have an amazing experience when they come into our offices. We want to make sure that it is easy, it's secure, and it's seamless. As our employees are becoming more mobile as part of dynamic work, a physical badge is just one more thing that can be lost or forgotten. And you guys also talked about a number of security concerns related to actual physical badges. OpenPath gives us a secure credential that is tied to something that we all have with us everywhere we go, our mobile phones. Um, it really is going to allow us to create that Apple Pay like smooth experience for our employees to access our spaces instead of needing to use a physical card and carry that around. You talked about the focus that OpenPath has on user experience, and that's something that we think a lot about as well. At this point, we're using OpenPath in 3 of our offices, and we're looking forward to expanding that more in the future.
Wow, that's excellent. And so we actually have some cool visuals that I'll put up on the screen so that folks can kind of see how you're using it today.
Yep.
Maybe if you could talk a little bit about sort of the deployment and also a little bit about how did you evaluate, OpenPath compared to some of the other solutions out there and think about, why this might be a better fit.
Sure. So, as a workplace technologies team, we evaluate a lot of different technologies. But for anything that we're trying out, we always make sure that we are testing it. For us, that usually means installing hardware somewhere in a test area or in a lab space in our offices. When we thought about access control, really our high level requirements were first, it had to be secure, it had to be reliable and work well. It needed to be a solution that would scale as we are growing as a company. And we also wanted to make sure that it included a tight integration with Okta, especially for directory user lifecycle management. That's incredibly important. We also really wanted to make sure that whatever solution we went with integrated well across our technology stack to give us the flexibility really around the experience that we create for our employees. So the ability to do things like tie physical access to health and safety screenings, visitor access, identify tailgating, things like that. And lastly, and almost most importantly, it really had to be easy for our users. Um, OpenPath addressed all of these requirements, and we felt like there were also additional advantages. One of the main things that was really helpful for us, and you mentioned it, was that OpenPath is backwards compatible with our existing physical badges. So as we go to roll this out to employees, we aren't doing a hard cutover. It gives us a lot of flexibility in terms of how we transition from our existing access control system over to OpenPath.
This new world order that we're in. What's kind of the plan for return to work, and how does OpenPath sort of fit into that? I'm sure a lot of the folks on the call today are figuring out their plans, and hearing from you would certainly be helpful for them.
Our top priority is health and safety, for sure. So we are closely watching the data. We're proceeding carefully. But with that, we're looking forward to welcoming more of our employees back into the office when the time is right. And we want to make sure that our offices are a wonderful place for our employees to work and to collaborate. So we're thinking about what are the things that we can do to make that a really great experience. We're thinking about things like integrating Envoy Protect. You mentioned that we're both an Envoy customer as well as an OpenPath customer. So we want to make it easy for our employees. So they have the ability to register to come into the office with Envoy Protect. When the time is right, they'll be able to fill out their health screening. When they come on site, they check in. And then through that integration, their OpenPath credentials are automatically enabled and they can get into the office. So that's just one example of how we're thinking about how the technology experience that we put together will help facilitate a smooth and a return to work that really feels great for our employees.
Well, that is great feedback. And I know that people will probably have questions for you given your expertise in the space and the process that you guys have been going through at Okta to think about both making the workplace easier for your employees, safer for your employees, and more secure for your company. So, our contact information is up on the screen. Brooke, thank you so much for the time today and for being a great partner and a great customer. Really appreciate the wisdom that you shared with us.
Thank you guys for being a tremendous partner, and I'm happy to be here.
Very cool. Sammy, thanks as always for your wisdom. And if anyone's interested in learning more about OpenPath, our contact information is up here. And enjoy.